Is it necessary to explain them one again or not? I did it in time lecture. Okay, give me a copybook. Okay. What is it?
Spinal cord. We have to draw same, right?
Yes,
Like
yes. I already draw. If you
Yes.
record
lecture. Yeah,
it
yeah.
in my lecture, that is the same. I explain one ascending and one
Yeah,
descending.
descending.
All another you receive from my lecture. That is the same.
that
Pons,
is, yeah. Then midbrain.
midbrain, thalamus,
Yeah.
internal capsule, and brain cortex. If you speak about motor analyzer, that is proprioceptive sensitivity and receptors in apparate of movement. And first sensory neuron for all ascending tracts were in spinal ganglion spinalis. From here, axons of this first neuron goes to spinal cord and makes what? Fasciculus gracilis and cuneatus. And this fascicles goes to the same
Nucleus gracilis and
nucleus.
nucleus
Yes. Second neuron, nucleus gracilis and cuneatus. Axons of this second neuron goes to opposite side. This is tractus bulbothalamicus or internal arcuate fibers. They makes decussatio lemniscorum. I put number 1, that is fasciculus gracilis, 2 fasciculus cuneatus, 3 decussatio lemniscorum, 4 bulbothalamic tract or internal arcuate fibers. Here it is trapezoid body, and above of trapezoid body lemniscus medialis. Lemniscus medialis, that is number 5. It continues into midbrain, and here the same. Lemniscus medialis, number 5, goes upward to the lateral nuclei of thalamus, and this is third neuron. And axon of the third neuron goes to brain cortex through internal capsule. What is the name of this tract? Tractus thalamocorticalis. Number 6. And cortical center of motor analyzer, that is gyrus precentralis and lobulus paracentralis. And it's conduct conscious proprioceptive sensitivity. Yes.
Okay.
If we speak about skin analyzer, for example, skin analyzer for temperature and pain, receptors in skin, first sensory neuron in spinal ganglion, and second neuron, help me, for temperature and pain.
The thoracic.
Proprius.
Proprius.
Yes, nucleus proprius, second neuron. This is commissura alba. This one is tractus spina thalamicus lateralis. In medulla, the same, spina thalamicus lateralis. In pons, it is lemniscus. No, in your textbook, this is lemniscus medialis. But I recommend you to answer lemniscus spinalis. This is lemniscus spinalis. If you will answer lemniscus medialis, it is not mistake. In textbook, lemniscus medialis. But more better, it is nucleosification, lemniscus spinalis. Here the same, lemniscus spinalis, lateral nuclei of thalamus, tractus thalama corticalis, and brain cortex, that is gyrus
Paracentralis.
Postcentralis.
And superior parietal lobe.
post
Centralis.
centralis.
And
centralis and superior parietal lobule. And if we speak about feeling of touch, here first neuron spinal ganglion and second neuron for feeling of touch, tactile sensitivity, substantia gelatinosa or gelatinosa. Then commissura alba, tractus spina thalamicus. What? Anterior. Here the same anterior spinothalamic tract. Then lemniscus spinalis, lateral nuclei of thalamus, tractus thalamocorticalis, and brain cortex. That is feeling of touch. And feeling of stereognosis. That is like in first diagram, fasciculus gracilis and cuneatus, nucleus gracilis, decussatio lemniscorum, internal arcuate fibers, lemniscus medialis, thalamus, and brain cortex. That is feeling of stereognosis. Clear? And two tracts for cerebellum. Here it is, yes, spinal cord, and that is pons and medulla. That is where is part of yes. This is pons, medulla. Here inferior peduncle of cerebellum, superior peduncle, and cortex of cerebellum. Clear? First neuron receptors in apparatus of movement, muscles, ligaments, capsules of joints. First neuron in spinal ganglion, second neuron nucleus thoracicus, and from thoracic nucleus axons goes to the same side and continues to medulla, and then goes to inferior peduncle and finish in cortex of cerebellum. Clear? That is number one, that is tractus spinocerebellaris posterior. Number two, inferior peduncle of cerebellum. And now anterior tract, the same receptors in apparatus of movement. First neuron in spinal ganglion, axons goes to spinal cord, and second neuron where nucleus intermedio medialis, axons goes to opposite side and makes tractus spinocerebellaris anterior. It was posterior, here it is anterior. I put here number 3, tractus spinocerebellaris anterior. Number 4, commissura alba. This is the same. Pons, medulla, inferior, superior peduncle, cerebellum. And this tract goes to medulla oblongata, goes to pons. And if you remember, I already explained roof of the fourth ventricle. Here was superior peduncle, here another superior peduncle, and what is between? Velum medullaris superior. And now this tract goes to superior peduncle, and through velum medullaris superior goes to opposite peduncle and goes to cortex of cerebellum. Clear? That is why number 5 here, that is velum medullare superior. And this is number 6, superior peduncle of cerebellum, pedunculus cerebellaris superior. That is 2 tracts, one tract without decussation, another 2 times, first in commissura alba, second decussation in velum medullaris superior. That is all ascending tracts, and now descending. Descending tracts, they are, some of them pyramidal, another extrapyramidal. Pyramidal tracts start from what? From brain cortex, from which gyrus? Yes. Gyrus precentralis. Yes, it is both. In third layer of cortex, that is center of proprioceptive sensitivity, 5th and 6th layers, pyramidal cells, they are beginning of pyramidal tracts. They are voluntary motor impulses. And can you give me a pen? Thank you. Cortica spinae from brain cortex below of knee of internal capsule. Then here in base of the peduncle, here it passes in midbrain. In pons below of trapezoid body, here. This is. Then it goes to pyramid of medulla, and here in pyramid, one tract goes to opposite side and continues to lateral funiculus and finishes in motor nuclei of anterior horn. This is, I put here, number one, that is tractus cortica spinalis, cortica spinalis, cortica spinalis, and here the same. And number two, cortica spinalis lateralis, and number three, decussatio pyramidum. Yes, that is decussatio pyramidum. Another tract goes to anterior funiculus, this one. And from here goes to opposite side, yes, commissura alba, and finish also in motor nucleus. That is why number four, cortica spinalis anterior, number five, commissura alba. This is second motor neuron, first in brain cortex, second motor nuclei in anterior horn. And from this motor nucleus
Muscles.
goes to striated muscles. That is both lateral and anterior cortical spinal tracts, and tractus cortica nuclearis. It is also pyramidal from brain cortex, passes through knee of what? Of internal capsule, and goes to motor nuclei of cranial nerves. For example, in midbrain, that is midbrain, in midbrain, at the level of superior colliculus, motor nucleus of which cranial nerve?
Oculomotor nerve.
Oculomotor, yes, it is that. And it goes to both nuclei on the right and on the left side. And at the level of inferior colliculus,
Trochlear.
who is that? Trochlear nerve. And it's also received from, goes to both nuclei on the right and on the left side. Then pons, in pons, it was third and here fourth. In pons, fifth, sixth, seventh. And what about eighth? Why I don't draw this nuclei for eighth? Because eighth nerve nuclei, they are sensory, they are not motor, and this all another, this nuclei, they are motor. That is why fifth nerve from both sides, then sixth also in both, but seventh nerve only to opposite side. This hemisphere supplies opposite nucleus, and from this hemisphere to this nucleus. That is why if you have tumor in one hemisphere, opposite facial nerve will not receive impulses. That is why half of the face will paralyze. And then in medulla oblongata we have motor nucleus for 9th, 10th, and 11th. They are one nucleus, it is nucleus ambiguous. I draw three, but that is one nucleus. 9th, 10th, and 11th. And 12th nerve has its own nucleus, nucleus nervi hypoglossy. And this nerve from both sides, this also, and here the same. But 12th nerve only in opposite side. that is tractus cortica nuclearis through knee of internal capsule, tractus cortica nuclearis. And last, extrapyramidal, main extrapyramidal tract, that is tractus rubra spinalis. Another tract, except rubra spinalis.
Olivospinalis,
Reticulospinalis, vestibulospinalis, and one more that is
Spine.
tectospinalis.
Yes. No, spina tectalis, it is ascending. But now we speak about descending tracts. And now, this is nucleus rubra, and this is tractus spinalis, and it finishes in motor nucleus, and from here goes to striated muscles. And this is the same. And now, one diagram, we show communication between red nucleus and brain cortex. Look here, that is cortex of brain. This is caudate nucleus, here it is thalamus. This is nucleus lentiformis, which consists of putamen and globus. From brain cortex, start tract which goes to putamen. This is tractus cortica strialis, number one, cortica strialis. From pallidum, start tract tractus pallida rubralis, goes to nucleus rubra. This tract has communication with medial nuclei of thalamus, with hypothalamic nucleus. All of they are structures for extrapyramidal system. And in this case, we will see that brain cortex, it supply putamen. Putamen has two-way connection with pallidum. Pallidum supply nucleus rubra, and nucleus rubra goes to motor nuclei and striated muscles. That is, this diagram is diagram of extrapyramidal system, and first neuron here is nucleus rubra, and second neuron is motor nucleus. And now descending tract from cerebellum. In this case, first neuron in cerebellum, second neuron the same in cerebellum, that is nucleus dentatus, and from nucleus dentatus we have tractus cerebella tegmentalis, and in this case nucleus rubra is third neuron, clear? And from third neuron continues to motor, and here it is, we speak about fourth neuron. And whole this tract is tractus cerebello rubra spinalis. But between nucleus dentatus and nucleus rubra, from here, cerebella, yes, it is tractus cerebella tegmentalis, and this tract passes through which peduncle of cerebellum? Superior peduncle. I put here number 1, that is cortica strialis, 2 pallida rubralis, 3 tractus rubra spinalis, and 4 decussatio
Pyramidalis and
tegmentalis
ventralis tegmenti. And now this is number 5, tractus cerebella tegmentalis, 6 superior peduncle of cerebellum, and that is all. All another labels here is present. Clear? Cerebella rubra spinalis, 4 neurons, and this is only rubra spinalis, first and second neuron, and communication with brain cortex. All of them here are present. This is extrapyramidal system, that is cerebella rubra spinalis. Well, I think that is all. Goodbye.